Good morning, all you positive people. Um, if you guys finished the warm up, we're gonna take some notes together. I want you guys to go into OneNote under class notes, and you're gonna go to the one that says Pythagorean theorem. So class notes, Pythagorean theorem. And it's gonna be a little different today. We're gonna take notes together. You're just gonna follow along with me, and you can either type or write in pen. You can change the colors. But I want you guys to follow along in the Pythagorean theorem section. And if you ever need to pause the video to write something down, just pause the video and do so. So, we're starting to do some geometry topics at the end of the year. And the first thing that we're going to look at is something called the Pythagorean theorem. For some of you guys, this might be reviews. For some of you guys, it might be something new. But the idea is we're going to start off with identifying different types of triangles. I'll introduce what the Pythagorean theorem is and what it applies to, and then we're going to get to practice using it. So, first of all, types of triangles. We have acute triangles. So that's a triangle where all the angles are less than 90 degrees. So we're all going to write this down. So triangles whose angles all measure less than 90 degrees. They're all acute angles. So acute angles are just angles that are smaller than 90 degrees. And so 90 degrees would be, a perfect L shape. This is what we call 90 degrees. So as long as it's less than that, for example, if all the angles are smaller than 90 degrees, it might look something like that. These are all less than that big angle right there. An obtuse triangle is where one of the angles is over 90 degrees. So triangles with an angle greater than 90 degrees. So for example, you could have a really wide angle that's bigger than the 90 degrees up here. That's an obtuse triangle. And a right triangle is just a triangle with a right angle. Triangles with a right angle, a 90-degree angle. So an example would be, here's my right angle. That's 90 degrees. This triangle right here would be a right triangle because it's got a 90-degree angle. Okay? So, one other thing about right triangles is, let's do blue. The side across the 90-degree angle, the big side, this is what we call the hypotenuse. So that is the largest side, and it's opposite the 90-degree angle. The largest side, which is going to be across from the 90-degree angle. What I mean by across, if here's a 90-degree angle and we go straight across, that's going to be across the 90-degree angle. So it's on the opposite side of the 90-degree angle. That's what we call the hypotenuse. So the largest, let me rewrite this. Across from the 90-degree angle is called the hypotenuse. And the other two sides are called the legs. So the other sides, we're going to call these both the legs. They're the sides that make the 90-degree angle. So now we have defined legs of a right triangle and the hypotenuse of a right triangle. Okay, and we know acute, obtuse, and right. So identify each triangle based on its angles. Is it acute, right, or obtuse? So all of these angles, 38, 71, and 71, is that going to be an acute triangle, a right triangle, or an obtuse triangle? Well, all these angles are less than 90. So if all the angles are less than 90, that's got to be an acute triangle. This one right here, this symbol right here means 90 degrees. That is our right angle. This is a right triangle. Another fact about triangles, all three angles have to add up to 180. So if you add up 71 and 71, that's 142, plus 38 is going to give you 180. So they're all going to add up to 180. 48 and 42 adds up to 90. So this angle must be 90 because 90 and 90 will give me that 180. And then 40 and 40 is 80. 80 plus 100 is 180. So that's always going to be the case. But that wasn't the question. Is it right, obtuse, or acute? This triangle right here has one angle that is greater than 90. So it's going to be an obtuse triangle. Okay. For 10, 11, and 12, see if you can answer those on your own. Is they right, acute, or obtuse? I'll give you guys a couple seconds. And time. So first one, the symbol here means 90 degrees. We have a right triangle here. None of these angles are over 90. So we have a acute. They're all under 90 degrees. And here we do have one angle that's 135 degrees, which is bigger than 90. So we have an obtuse triangle. Okay. The purpose of this is because this Pythagorean theorem, which, I mean, again, you guys have probably heard this before, the whole a squared plus b squared equals c squared thing. This only applies to right triangles, so we need to be able to identify which triangles are right triangles. So there's a question that I want to be able to answer at the end of this video. If Devin is catching and a runner is trying to steal second base, how far does he have to throw the ball? We're going to answer this question later. The information that we know is that a baseball diamond is in the shape of a square and each bases are 90 feet apart from each other. And somehow we're going to try to find out how far does the catcher have to throw. So if Devin's catching, he has to throw a guy at second. What's that distance? The Pythagorean theorem is going to help us. So here it is. Pythagorean theorem. So as long as we have a right triangle with side lengths A and B, so if a right triangle we'll call the length of the legs A and B. So here's my right triangle. Let's try that again. Come on, make the shape work. If a right triangle with legs A and B, and we're going to call the hypotenuse C. Then A squared plus B squared. If we square the two legs and add them together, that's always going to be the square of the third leg. So if I'm given a right triangle with side lengths with legs A, B, and the hypotenuse, which is across the 90-degree angle, we're going to call that C. Then if I take this length and that length, square them and add them together, it's going to give me the square of the third length, which seems kind of not useful, but actually this formula is going to allow us to find out how far Devin has to throw the ball to throw a kid out stealing second base. And it's a very useful anytime you're trying to find out what a diagonal distance is. And there's other uses, but we'll talk about that in class next time I'm there. So in each of these triangles from before, determine if the Pythagorean theorem applies. So the Pythagorean theorem only applies for right triangles. So it needs to be a right triangle in order to use the Pythagorean theorem. So can we use the Pythagorean theorem on triangle 1? The answer is no, because it's not a right triangle. There's no 90-degree angle. it's not a right triangle. The second one, can we use the Pythagorean theorem? Would it apply? And the answer is yes, because it does have a right angle. Yes, because it's a right triangle. Okay. And last one, is this a right triangle? No, it's got a 100-degree angle. There's no 90-degree angle. No, because it's not a right triangle. Right. So make sure we're writing this down kind of as we're going. And if you need to stop, pause the video, feel free. If you need to rewind it, feel free. But again, we need a right triangle. And if I call the legs A and B and the hypotenuse C, then the square of the sum of the square of the legs, A squared plus B squared, has to be the square of the hypotenuse. Okay? So an example. The lengths of the three sides are given for several right triangles. So we have three right triangles right here. For each, write an equation that expresses the relationship between them. And so the relationship of the three sides of a right triangle is that A squared plus B squared equals C squared, and C is the hypotenuse, so just remember that's the largest side. Not the largest side. It doesn't matter which you choose for A and B, but it does matter that C is always the largest. So for number one, the biggest side here is 10, so that has to be C. It doesn't matter which one I call A and B. Now the relationship is that A squared plus B squared equals C squared. So in this case, if A is 6, so let me write A squared plus B squared equals C squared first. So this is true if it's a right triangle. A is 6, so we have 6 squared. B is 8, so we have 8 squared. And C is 10, so we have 10 squared. So that's the relationship. 6 squared plus 8 squared does equal 10 squared. That's 36 and 64, which adds up to 100. And 10 squared is also 100. Yep. Okay. Now, again, C has got to be the biggest. So the square root of 5, square root of 3, square root of 8. Square root of 8 is the largest, so that has to be C. The other ones are going to be A and B. It doesn't matter which one's A, which one's B. So if I know that A squared plus B squared equals C squared, just plug in the square root of 5 squared plus B squared, B is square root of 3, equals C squared, C is the square root of 8. And the square root of 5 squared is just 5. The square root of 3 squared is just 3. 5 plus 3 is 8, which is the same thing as the square root of 8 squared. Last but not least, we have 5, square root of 5 and 30. The square root of 30 is, the square root of 25 is 5. So 30 is a little bit bigger than 25. So it's going to be, this one's going to be the biggest side. This one's going to be bigger than 5. So that's got to be C. The square root of 5 is going to be less than 5. It doesn't matter. If that's C, we can call that one A and that one B. So if I want to use Pythagorean theorem again, then replace A with 5. So 5 squared plus square root of 5 squared, which is B, equals C squared, which is square root of 30 squared. And that does work out. That's going to be 25 plus 5, which is 30, and the square root of 30 squared is also 30. Okay, so that's just writing down the relationship. Now in this example, we're going to actually find the length of the missing side using this Pythagorean theorem. So in any case, we're going to label the sides A, B, and C, and then use the formula to find the missing side. So the longest side is the side across the 90-degree angle, so that's got to be C. That's the hypotenuse. The other legs we can call A and B. And what the Pythagorean theorem tells us is that A squared plus B squared equals C squared. So if A is 4, we have 4 squared. If B is 3, we have 3 squared. And C is X, so we're going to call it X squared. So what must X be? Well, 4 squared is 16. 3 squared is 9. That has to equal that third side squared. 16 and 9 is 25. So if I want to find out what X is, X times itself equals 25. If you can do this in your head, I think it ends up being 5. But if not, that's okay. We can just square root both sides. And the square root of 25, you can put in the calculator, is 5. Okay, so X is 5. So we found the missing side. Another example here. Here's the right angle. So the hypotenuse is the one across from that. We'll call this C. The other ones we can call A and B. Doesn't matter which one's A and which one's B. If A squared plus B squared equals C squared, and A is 6, so we're going to have 6 squared. If B is 3, we're going to have 3 squared. I'm just going to call that side C squared. 6 times 6 is 36. 3 times 3 is 9. That has to add up to C squared. 36 and 9 is 45. Now this one we're not going to be doing in their head because the square root of 45 is not going to be a nice whole number, but that's fine. If I square root both sides, I can get C by itself. So C is going to be whatever the square root of 45 is. That's the exact answer. If we want to approximate that, I could just type into OneNote. And if you have your calculator, you can do that too. I type SQRT 45 in the parentheses. And right equals, it'll tell me that it's about 6.7. So that is the third side. The exact value is whatever the square root of 45 is. The approximation is 6.7. Okay. Another example right here. Label the sides A, B, and C and plug them into the Pythagorean theorem. A squared plus B squared equals C squared. This is the largest side, so we're going to call that C. It's across the 90-degree angle. So we have A and B. So we have 12 squared plus B is X, and we'll call it X squared equals C squared, which is 13. So that's just going to be 144 plus X squared. 13 squared is 169. Now in this case, we actually have to solve for X squared. So if I want to get rid of the 144, I just subtract it on both sides. 169 minus 144 is 25. And if X squared is 25, square root both sides. And the square root of 25 actually comes out to be exactly 5. Okay. I'm going to let you guys try to do this last one on your own. You're going to get a decimal, which is fine. Just pause the video and work on it. I'm going to put the answer up in a second. And now that you've unpaused the video, let's see if anyone got it. In this case, X is approximately 8.6. So if anyone got that, nice job. We can talk about it in class. If not, you'll get more practice for sure. And then finally, if Devin's catching and a runner is trying to steal second, how far does he have to throw the ball? We can now answer this question. The baseball field is in the shape of a diamond, which is going with right angles. So we have 90-degree angles here. So Devin's right here. Second base is right here. We have first and third. There's 90 feet between the bases. So he needs to throw it across. So we want to find out how big that is. And we can do that by building a right triangle here. Where this distance across is across the 90-degree angle. So that's the hypotenuse C. We have A and B. So with this right triangle right here, we can use Pythagorean theorem to find out what that distance across is. So I'm going to call that C. So A squared plus B squared equals C squared. And A is 90, and so is B. So 90 squared plus 90 squared equals C squared. 90 times 90 is 8100 equals C squared. 8100 and 8100 is 16,200. 16,200. So if I want to find that distance, we got to take the square root of that number. And if you put that in your calculator, you do the square root of 16,200. The computer's being a little slow. SQRT. So how far does the catcher throw? How far is home plate to second base? It's about 127.3 feet, which is cool. Anyways, that's it. You guys can start the homework, and I'll see you guys next week.